Hi everyone, so I'm asked sometimes how do we train in Natori Ryu, and what we have is a selection of online courses, and people question, oh, is it any good? How do you do it? What do you do for these online courses? So we have multiple online courses, many of them, and we do everything from swordsmanship to scouting to the sort of like the way of rope, binding, capturing. There's lots and lots of stuff that we have. So what I'm going to do here is just show you a couple of videos from Simon Proctor, one of our students, and he is a good example of how he puts in his student submissions, and he puts them into the Jodai. Now anyone can join these courses. You just got to become a member of Natori, which is very cheap, and then we do the courses for as little amount of money as possible so that you guys can get on with training. There are major courses and minor courses. So what I'm going to do now is just leave you with Simon Proctor and an example of how he submits his courses. And if you want to join us, please have a look at Facebook Natori Ryu Hub and join us there and ask how to be a member.
Here's what we're going to do now is we're going to show how to take angles using our protractor. We've got this tree lined up in front of me, which is going to be point B, I'm on point A, and then we're going to take a reading to this which is 0, and then we're going to move 10 metres at a right angle and take another bearing and work out what the angle is between the two, and work out the angles of our triangle. Okay, so we've paced out 10 metres at a right angle from our starting point to point B, and we've took our angle, or we're going to take our angle. So we've found our angle to be roughly about 22 degrees from where we are. So what we're going to do now, we're going to take those two coordinates, we're going to map them out onto our piece of paper, find out the distance, and then come back to see if we're correct. Okay, so what we've done now is we've got our point A, which is this corner, point B, which is to our target, and across the base here we've got our 10 metre baseline. So what we're going to do now is put our protractor on, and we know that it was 22 degrees, so there's 10, 22, and we're going to mark our line. So what we're going to do now is we're going to join the end of our baseline to this line, carry over to the lines across, and then we can work out our angles from that, and in turn find out our distance. Okay, so what we've done now is we've joined our lines up on our bearing of 22 degrees. Where these lines cross is our distance to the tree using our 10 metre baselines. Each one of these grooves on the grid of paper represents 2 metres. So we know that that's 10 metres across here, so now all we have to do is count how many squares up to where it crosses, and we'll have our distance. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. So 12 squares, each square is 2 metres, so that should be 24 metres from our starting point to the tree.
Okay, so what we're going to do now is we're going to use the equilateral and the 30, 60, 90 triangles to establish the distance between A and C. So to do this, we're going to stand facing our target, take a bearing of 60 degrees so we can establish a baseline. We're going to continue walking our baseline until we get back to within 60 degrees of point C. At this point, we can pace out our baseline, and this distance should be the same from points A to B, B to C and C to A, as all of the angles are 60 degrees and the distances should be the same. This is how we use the equilateral triangle. However, if using the equilateral triangle over long distances isn't an option, or there's an obstacle in your path, you can take your original bearing of 60 degrees from your target until you get and establish your baseline until you get to 90 degrees of your target. Then if you use to pace your baseline and then double the distance, you'll get the same result, as this is known as the 30, 60, 90 triangle. Okay, so what we're going to do now is measure the distance from A to C using the irregular scalene triangle, plot it onto gridded paper and use a protractor and ruler to find the distance. So because we're unable to move off at a right angle to get our 10 metre baseline, we have to take a second bearing to an object at point B and pace out our 10 metres so we can establish the baseline. Okay, so we took our bearing, which it was 113 degrees, and we was able to pace out our 10 metre baseline to point B. So what we're going to do now is take another bearing to point C. Okay, we've took our second angle now from B to C, and what we're going to do is plot these angles and lines onto gridded paper, measure the baseline, and then use that to measure the distance between A and C. Okay, so we've used our ruler and we've established our baseline to be 5 centimetres over 10 metres. Okay, so we used the ruler to measure our baseline. We found it to be 10 metres over 5 centimetres. So we measured the distance from A to C and found it to be exactly 10 centimetres. So if our baseline was 5 centimetres over 10 metres, then the distance from A to C is 20 metres.